In this video, I am going to show you how I use different Docker products to increase my productivity and how you can do it too with a hands-on demo. So this is the project that we are going to be using throughout this video to learn about different Docker products. This project is a system monitoring dashboard that will collect system data such as CPU, memory, disk, and also showcase them on the browser. We are using Flask library along with Redis. Redis is used to store 5 recent metrics, and we will use this project to deploy it on Docker. But we are not just containerizing this application, we will also be using advanced Docker tools to enhance development, security, and testing. Docker is the most popular container technology and is used by almost every company these days. So learning all these tools and having hands-on knowledge on Docker products is going to help you in your career. By the end of this tutorial, you will be able to package your applications as Docker container, run and manage them using Docker Desktop, use Docker Compose and Compose Watch to manage multiple Docker containers and also for live reloading, scan your Docker images using Docker Scout, speed up your build using Docker Build Cloud, and lastly, automate testing using TestContainers. This video is sponsored by Docker and I am a Docker captain, so I'm going to show you everything through hands-on demo. So make sure you watch this video till the end. Let's go. Alright, let's get started. The first step is to clone this repository, and you can find the link of this repository in the video description. Anyone can do this project, including beginners, because I've added all the steps, all the commands, including Docker file, Docker Compose file in the README section of this repository. So make sure you watch this video till the end and also practice along with me because all the steps are already here. Now the first step is to clone this repository. So click on this code button, copy the URL, and I'm going to go to my terminal. In my terminal, I'm going to run the command git clone and paste this URL, and it will go ahead and start cloning this repo. Now I have this repository downloaded in my local machine, and I'm going to open this up in my VS Code. You can see the project is here. We have all the files required. So this is the app.py. As you can see, it is using all these different libraries: Flask, psutil, datetime, Redis, OS, etc. To give you a general information about this project is collecting system metrics, as I've already mentioned, which is the CPU, memory, and disk. And once it collects the metric, it is going to refresh every 5 seconds. It is also going to store 5 recent metrics in the Redis. If you want to know more about this project, all you can do is copy this and go to ChatGPT and ask it to explain it to you. This video is not about the code, it is about learning how to use Docker to deploy this application. Before we use Docker to containerize this, let's confirm if this is running in our local machine or not. To run this Python project, I'm going to open up my terminal, and in the terminal, I'm going to say python3 app.py. For you to run this, you need to have Python installed. You also need to install Redis. So if you want help, let me know in the comment section, but you can easily install Redis from the official documentation. So if you search for Redis, you can just go to this document and then download it for your Windows, Linux, Mac OS, anything. I have Redis already installed in my machine, so I'm going to just show you how to run this code. So in the terminal, I'm going to say python3 app.py and press enter. Once I press enter, I get this error saying no module named Flask. So I need to install this module. So I'm going to say pip3 install Flask. Flask is a dependency here which is required for this application to run. Now when I press enter, it goes ahead and starts installing Flask. Once I install Flask and run this again, I'm going to get another error saying psutil not installed. So this application requires different dependencies like Flask, psutil, Redis, datetime, etc. And this is what Docker actually solves. I have all this requirements or dependency present inside this requirements.txt file. So rather than installing them one by one, all you need to do is say pip3 install -r and name of the file requirements.txt, which is going to install everything. Once it is installed, I'm going to say the python3 app.py command again to run it. And you can see now it is running, and you can check that on your localhost 5001. So let's go to localhost 5001, and this is our application which is running, showing us CPU, memory, and disk. You can see very soon it's going to be updated, and it updates every 5 seconds. So very soon you will see it is updated now, and you can also see the logs here. Now, as I told you, this application is also going to store some data in Redis. So let me show you how that works. In my new terminal, I'm going to say Redis -cli. You can only run this when you have Redis installed. And now to show what metrics do I have, I'll say keys and then star. This shows me that I have metrics stored here. So let's see what is the metric type is list. So if I want to see this, I'm going to say, okay, L range metrics 0 to -1. Okay, so you can see these are the 5 latest metrics that are stored inside Redis. So we have an application that is showing us metrics and also storing it in Redis. Interesting project, right? I want you to deploy this. So we have now locally deployed this application. We want to deploy this using Docker and later on also use advanced Docker tools to enhance development, security, making it fast, reliable, and a lot more. Now, before we use Docker to containerize our application, let me quickly explain you what is Docker and why do we use it. So Docker is a tool that lets you package your applications along with its dependencies and everything necessary into a container so that it can run anywhere, be it Linux, Mac OS, Windows, or local development, staging, production, anywhere. It will run the same because this container has your applications, dependencies, and everything necessary to run it. Now that you understood what is Docker, let's see it in action. It's always a best practice to run your application locally before you containerize it. And now if you want to containerize it or run this as a Docker container, the first step is to create a Docker file. So we need to first create a Docker file out of which we will create a Docker image and then run it as a Docker container. So what is Docker file? A Docker file is a set of instructions that will tell how you want the image to be. So we are going to be creating a Docker file. So now to create a Docker file, you need to name it the same way as it is, which is Docker file. And you can see this Docker logo as well. GitHub Copilot to create this Docker file. You can also use Copilot or you can directly copy it from the README section. So I'm going to click on this here and ask Copilot to give me the Docker file. So we have this file here which is using Python 3.9 as the base image, work directory as /app, requirements.txt is copied. Okay, let's use this. And now we have this Docker file ready. If you want to learn about all these different instructions, I have a separate video created. And if you don't know what from means or work directory means or copy means, I will highly recommend you to check that out. These are all Docker instructions that tell Docker how you want the image to be. So we have this Docker file here. Let's go ahead and run this. To run this, we need to run the command docker build. So docker build -t and the name of the image you want. Okay, yeah. GitHub Copilot has also given us this command. So I'm going to copy this. So the command is docker build -t and the name of the image is going to be my Flask app dot. Once I press enter, you can see the image is now being created from this Docker file. And now the image is created. You can check your image by simply running docker images, but a better way is to check it through Docker desktop. So a Docker desktop is where you can see all your different images, containers, volumes, builds, etc. This is a graphical user interface to manage your image, containers, and volumes. I have this Docker desktop installed. If you don't have it installed, you can simply go to the browser and just search for Docker desktop. This is the page, or else you can just go to the repository. In the repository, you can find steps and click on this link to install Docker desktop. You can find Docker desktop here. In this video, we are going to be learning about Docker desktop. We are also going to learn about Docker Scout, test containers, build cloud, Docker Compose watch, and lot more. So make sure you stick to the video till the end. I have this Docker desktop already installed. If you don't have it installed, you can go ahead and install it from this official documentation. You can see images here. In this images, you can see this my Flask is the image that is created 22 seconds ago. When I click on this image, I can see all the different layers here. So you can see these are all the different layers, and I can go ahead and run this image as a container as well. So when I click on run option here, optional settings where I can fill in what should I name this. So I can name this my monitoring container. So monitoring container, and the host port on which I want to run this. So let's say I want to run this on maybe 9000. So I'll say 9000 and then click on run. Once you click on run, you can see the logs as well. And if I go to my browser, open up localhost :9000, which is where my container is running. So you can see the container is now running, and you can see the CPU usage, memory usage, disk usage for the container. So this is now running as a Docker container. If I want, I can share this Docker container or Docker image with you, and anyone in the world can run this container from their own laptop. Now, before you run your container, you need to always make sure that your images are secured. So if I click on this, I have an option to run analysis or to check if my images is secure or not, what security issues are present, what vulnerabilities are present. So you can check that by using Docker Scout. Docker Scout is another product by Docker which lets you scan your images for any security issues before you actually run them. Doing this is very important because there are so many security concerns, and every company wants you to have secure images, follow security practices. So let's try to run a security analysis on this image here. So I'm going to say start analysis. It will go ahead and start analyzing to check what common vulnerabilities are present and what can I do to make it more secure. You can in fact also do the same using the Docker Scout command. You can also run Docker Scout with the name of your image, or you can simply run Docker Scout help, and you can see how you can run different commands here. But Docker desktops give you a good graphical user interface, so you can always see them graphically here. You can see at all the different layers you have vulnerabilities present. There are 0 critical severity, high severities are 0, 7 low severity here in the first layer, and you can also click on them to learn about more. You can see 3 different high severity vulnerabilities. When you click on this here, you can also go and read about it more on what is this about, why is this coming up, what should we do, and so on. So this is a good tool to make sure your applications are secure, your images are secure before you deploy them into production. So this is Docker Scout. Now in this application we have two main things, the Flask application itself and also the Redis, which is used to store recent metrics. So we are going to be using two different containers, and when you have multiple containers that you want to manage, you need to use something known as Docker Compose. So Docker Compose is a tool for defining and running multi-container applications. To start using Docker Compose, you need to create a file named as dockercompose.yml. So it's going to be dockercompose.yml. Inside this file, we need to define the specifications about different Docker containers that we want to run. And using this, Docker Compose will run all of them all together and manage multiple containers at once. So I have this Docker Compose file already created, which you can go and copy from this repository here. So I'm going to copy this and paste it here. In fact, you can also ask GitHub Copilot if you want. You can ask it to create it for you if you don't know, but I have it already provided to make sure you don't face any issues. Now inside this Docker Compose file, we have two different services. We have the web service and also the Redis service. Web service is for the Flask application, and we have Redis service which is running on 6379 using the Redis latest image to store our metrics data. If you want to run this, you need to run the command Docker Compose. Before you run the command, make sure you have Docker Compose installed in your laptop. So I can show you that Docker Compose is installed for me, which is version 2.32.4. So rather than running these containers individually, I can now run them all together. Maybe I can have like 3, 4, 5, 6, 7 containers inside this Docker Compose file, and I can run them all together at once with a single command by saying Docker Compose up -d to make it in detached mode. Once I run this, you can see the container has now been started, and I can also check that in my Docker desktop here. So if you go to containers section, you can see the two containers which are running, which is Redis and the web application here. So when I click on this, I can see my application is running inside a container now. Amazing, right? So this is how you can use Docker Compose to manage multiple containers. Now let's take a scenario. As you can see in this application, we have my system monitoring dashboard. Let's say you want to make a change. Maybe you want to change this color or the text here, or maybe the outline here, something else. Or you want to make a change in your application backend logic, anything. Whenever you make a change, you need to run the command to create the image again, then run the container again, and so on, which is a very manual and time consuming task. What if I can tell you that there's an option where you can do this automatically? Before I show you that, let me show you how is the manual process done. In this index.html, I have my system monitoring dashboard message here, which you can see in here. Let's say I want to change this message to new system monitoring dashboard. When I save this and I refresh, this is not going to be reflected unless and until I create a new image. So I need to run the command my image1 dot, and this will go ahead and create the image. Notice how long it will take to create the image. It took around like 3.4 seconds something. And now when I go to my Docker desktop, I can see a new image being created, which is my image1. Now to run this new image, I'm going to say run, and I can run this, let's say, on 5002 instead of 5001. When I click on run, and now if I go to 5002, you can see it says new system monitoring dashboard. So whenever you make a change, you need to recreate the image, then run the container out of it, and then you will see the updated change. But with using Docker Compose Watch, you can automate this process. So Docker Compose Watch is an attribute that automatically updates and previews your running Compose services as you edit and save your code. Let me show you how it works. So in your Compose file, you first need to add a section saying develop watch, and you can add a criteria. Either it can sync it or it can also restart it. So if I want to sync it, let's say just sync it and then show the updated changes, I can show it, or I can also ask it to restart the container for me. So in this documentation, you can read more about Docker Compose Watch. And if you scroll down, you can find sync option here, which is the action to set sync. Compose will make sure that any changes you make to the file will automatically match with the corresponding files. You also have option for sync plus restart, which is going to restart whenever you make a change. So let me show you how this works in action. First of all, I'm going to go and stop any running containers and also images. I'm going to delete them. Okay, and also delete any existing image. Alright, now it's all fresh. Let's go here. You can see in the Docker Compose I have this develop section added with the watch saying action is going to be sync plus restart, which means anytime I make a change either in this app.py or in this index.html, it will automatically update it. You don't need to do any manual configuration. This will save a lot of time. There are many times where our application is automated through a pipeline and you cannot do any manual changes. This is where you can use Compose Watch. To use Compose Watch, you need to first add this develop watch section in your Compose file, and then you can say Docker Compose Watch to enable it. Okay. Alright, there has to be no space. Let's save it again and then run the Docker Compose Watch again. And now you can see it's pulling all the images, and if it is fine, it will show you that it has started watching your containers. Alright, finally you can see watch is enabled now. Notice how long it took, around 198 seconds to create a build. And we need to do something about it. We need to make sure that the builds are doing faster. But for now, let me show you how this Compose Watch works. So right now in this index.html, we have new system monitoring dashboard. And you can see new system monitoring dashboard. And when I go to my browser, you can see it's been updated automatically. Let's make a change from this new, make it lol. Once I save it, you can see a message here saying syncing and restarting service web after one changes were detected. So when I refresh now, without creating any new image or without creating any new container, you can see the change has been updated automatically. Let's try it again one more time. Instead of this, I'm going to say Cloud Champ and save it again. So you can see the message here is always going to be shown whenever you make a change. So it says syncing and restarting service web after one changes were detected. And now if I refresh, you can see the change has been updated here. So this is a very good tool that will save you a lot of time and will also help you automate the process of recreating or restarting whenever you make a change. This can also be used in your CI/CD pipelines so that whenever you make a change in your code, in any of your files, Docker Compose will get to know and automatically sync, restart, depending on what action you have added inside your Docker Compose file. So let me show you again. Let's say we type sponsored by Docker and save it. Now you will see the same message being shown again, which says syncing and restarting service web after one changes were detected. And if I refresh this page, you can see the message being updated here. So similarly, any change you make will automatically be updated using Docker Compose Watch. And if you want to learn more about Compose Watch, you can go here in the official documentation and see other options that you can use in your projects. So far, we have seen so many amazing Docker products to help you secure your images, manage multiple containers, also detect any changes that you make. But the problem here is, notice how long it took to create or build an image. It took around 198.5 seconds, which is a huge time. Maybe your application will give you a timeout issue if it took that many time. So to solve this issue, we have another great product by Docker, which is Docker Build Cloud. Using Docker Build Cloud, you can create your images faster. Docker Build Cloud is a service that lets you build your images faster both locally and in CI. How Docker Build works is using the buildx command. Let me show you in action. So right now, all our builds were taking a lot of time, but now with using Docker buildx, you can do it very fast. To start using Docker Build Cloud for faster builds, you need to first install it, and you can click on choose plan option. This comes already installed with the Docker desktop. So if you install Docker desktop, you get Docker Scout, Docker Build, buildx, Docker Compose, everything. So I have it already installed. I can show you by running Docker buildx version command, and you can see it's already there. I also have some builds already created. So if I show by running Docker buildx, you can see these are all different builds that I've created. And if you want to create a new one, you can follow the commands in the README section here. So Docker buildx create a new builder. So I'm going to say Docker buildx create -- name, and name is going to be, let's say, Flash, because it creates Docker images in the Flash, and then I'm going to use it. So I'll say -- use. Now this Docker buildx build has been created, and you can also confirm this in the Docker desktop. So if I go to Docker desktop and click on this builds option here, you can see the current build which is selected is Flash. After you run the command, if you want to create an image using Docker build cloud, you need to say docker build x build hyphen platform. You can mention it for Linux, AMD or ARM64. Then the name of your image. So let's say my image, or maybe like just image, and the latest dot. You can in fact also pass your Docker Hub repository here, so to directly push your image from your local machine. Right now you can see it's taking around 6.7 or maybe long time. Very soon after we recreate it, it will take less time because Docker build will collect cache and it will reuse the cache rather than doing it from scratch. So let's see how long it will take for this image to be created. Alright, finally the image has been created, and if you see here, it took around 643 seconds to create this image, which is a huge time. Now, as we were using Docker build cloud, next time when we create this image, it is not going to take that much time. Let's try again. So when I say Docker build x again this time, you can see now it's just taking 1.6 seconds to create the same image, because when using Docker build cloud, the image building process is not done locally in your laptop. It is done on the cloud. So next time when I do the same thing again, you can see it's not going to take that much time. It will simply just take less time compared to what it took initially. So using Docker build cloud, you can save your time, you can save resources of your laptop, because this image building process is done on the cloud. So this is how you can use Docker build cloud to save time and to save resources of your laptop. Now let's look at test containers. Test containers is another great tool by Docker which lets you test your application on a temporary Docker container. So in our application here, we have Redis. Let's say you don't have Redis installed in your laptop. So how can you test it? You can use test containers for that. Similarly, imagine you're working on a Postgres application. You can use test containers to just test it without installing the database in your local machine. So using test containers, you can test your databases, APIs, etc. without actually installing them. It will be testing on a container which is going to be temporary, and after the test, it will be deleted. To show you in action, so I'm going to be creating a test-app.py file. Inside this, we will add a simple test to check Redis connection. So here I have a file named as test_app.py, in which we are going to be using test containers to test out Redis, also Flask, and to check if the metrics are being exposed or not. So you can go ahead and read this code, or you can also ask ChatGPT to explain you this code. But this is simply a file created to test out Redis, Flask, and metrics. When we execute this, it is going to create a temporary Redis container to check out Redis database connection, to check out Flask, and also to check out metrics, which is a very good way, because whenever you create an application, you always need to create test cases, and you do it generally in the local machine. But using test containers, you can do the same process in the container, and then you can always delete it. It is always going to be temporary. So let's try this out. To use this, you need to have PyTest installed. So I think I have PyTest installed. So I'm going to say Python 3 -m PyTest, and then the name of the app, which is test_app.py. Once I do this, it is going to go ahead and start executing the test, and very soon we can see it collected 2 items if it passes or not. Okay, so the tests have been passed, and you can see 2 passed tests, and you have 1 warning for SSL, which is okay because it's just a warning. So this is how I can use test containers to test my code right in the container in a temporary way without installing anything. And you can use test containers for every language, maybe Java, Go, Python, .NET, any language that you're working on. Right now we're using it Python, but if you're working with Node.js or any other language, you can go ahead and use it. You can see it is using testcontainers.postgres to try out or testing out Postgres, but we used it with Redis because we are using Redis as our database in the application. You also have the test container cloud option. So test container cloud is a paid offering, but if you want to use it for your local projects, you can also use the test container default or the desktop option. So far we have seen so many amazing Docker products, including Docker Desktop, Docker Scout, Docker Compose Watch, Docker BuildX to save build time, and also test containers to test out your code and to make sure it is reliable. If you learn all these tools properly, you can work with any similar tools, and it will also help you in your current projects. So I hope you will try out this project along with me. Alright, so this was our video on how you can use different Docker products to increase your productivity. In this video, we have seen different Docker tools like Docker Desktop, Docker Scout, Docker Init, also Docker Compose, Compose Watch, Docker Build Cloud, and test containers. I hope this video was informative. If you have any questions, any doubt, do let me know in the comment section. And I hope you will do this video along with me. So make sure you complete the project and also share your learning on LinkedIn. Thank you and have a good day.